I knew I'd run out of time. So, part 2 ensues. Okay, we were working on table G, all the intricacies of how to use it. We are going to continue figuring out these problems here using table G. We're going to find the mass of solute that precipitates after a change in temperature. Because remember, the hotter the liquid, the more solid can dissolve. But if you cool that down, whatever was dissolved in there might fall out, not be soluble anymore. So those are the math things that we're figuring out in this particular lesson. We're finishing up lecture 5. So I was trying to solve this one, saturated solution of ammonium chloride, NH4Cl. This curve of interest is at 75 degrees. It's saturated, so we know we've got about 65 grams of material dissolved in there. But we cool it down to 15 degrees. And at 15 degrees, it looks like maybe only about 35 grams would dissolve. So when you subtract the two, you get 30 grams difference. If you were to cool that solution down, about 30 grams of material would precipitate to the bottom. So subtraction. Okay, let's try another one. Okay, do lots of examples here, and so that we can get the concept of how we use this chart. A saturated solution of potassium nitrate at 50 Celsius is cooled down to 25. So let's start with our temperatures. We're given 50 and 25. And we're talking about KNO3, this very steep curve right there, that one. Boop. Smartboard's a little out of calibration, so let's see what we can do. We're saturated at 50, so we're right on the line. Looks to be about 80 grams of material dissolved in there. Then we drop it down to 25, and we're about there, about 40 grams of material. So if you do the subtraction, you'll see that 40 grams of material, potassium nitrate, would precipitate to the bottom of our test tube or beaker. Let's try some more of these things. Ooh, different type of problem. Let's do it. This one is focused on finding the mass of solute that could be added after a change in temperature. So the problems look kind of like this. A saturated solution of a chemical, ammonium chloride, at 55. So let's highlight ammonium chloride. At 55 degrees, it's saturated, so we're right there at about 55 grams. And it's heated up to 65. So you increase the temperature by 10 degrees. Now at 65, it looks like 60 grams of material would dissolve. So 60 grams minus 55 grams means you could add 5 grams more. As you increase the temperature, you can add more solute. So at the higher temperature, you take away the lower temperature solubility and you find the difference again. Let's see what else kind of problems we got here. Saturated solution, different chemical, potassium nitrate in this case, is at 20 degrees. So 20 degrees, potassium nitrate, the super steep curve. Okay, at 20 degrees, we're saturated, so we're right on the line at about, 35 grams of material. And we are going to heat it up to 70 degrees. At 70 degrees, whoa, huge solubility, about 125 grams. 125 grams minus 35 grams, let's see. It looks like you could add 90 more grams of material by heating that solution up. That's pretty huge change in solubility over that temperature range. Let's see what other kind of problems we got to solve. Finding the mass that's dissolved if the amount of solvent, aka water, is something other than 100 grams. So for example, how many grams of KNO3 can be dissolved in 50 grams of water at 40 degrees Celsius? This requires, 1, to find the graph value of how much could dissolve, and 2, paying attention to that 50 grams versus that 100 grams. Remember, if you've got half the H2O, then you got to equal half the solute. And vice versa. If you've got double the H2O, twice the H2O, then you're going to double the solute. Now, in this particular example, 50 grams of water, 40 degrees Celsius. So we got 40 Celsius. KNO3, and it says, boom, KNO3 will dissolve at 40 degrees. You're going to get about 65 grams. So 65 grams in 100 grams of water. But we don't have 100 grams of water. We've got 50, and 50 is 1/2 of 100. So I'm going to divide both of these by 2. 65 over 2 is 32.5 in 50 grams H2O now. So your second step after you read your value is to divide so that you get into the right solute amount, or solvent amount, pardon me. Another example where we're not going to divide, we're actually going to double in this case. So I'm going to erase my work part. I'm going to keep my notes about doubling or halving. And here we go. We got a different formula, or a different compound. KNO3, no, it's the same one. 50 Celsius. 50 Celsius, KNO3, how much dissolves? We got, looks like about 80 to me. So 80 grams KNO3 in 100 grams water. But we don't have 100 grams of water in our problem. We've got 2,000 grams. Well, this is times 20. So this is not 10 times, but 20 times more. So we're going to multiply by 20 to get our answer. 80 times 20 is 1,600 grams of KNO3 in 2,000 grams of water. So if you double, triple, quadruple times 20 your water amount, you got to double, triple times 20 your solute amount. Last one, I think, and then we're almost out of time. Yep. How many grams of KNO3 can be dissolved in 25 grams of water? So this way, 25 is 1/4 of 100, but we're going to use the same idea. We're going to halve it, or quarter it, or double it, or triple it. 35 degrees at 30 Celsius, we've got KNO3. Its solubility, we'll say it's 45 grams. So we got 45 grams KNO3 in 100 grams of water. Well, the relationship between 25 and 100 is 1/4. So 25 goes into 100 4 times. So you got to divide this whole section by 4. First, you find your value. Second, you divide to get into the right amount of solvent. 45 over 4, oh, gee, that's going to be like 10 some decimals here. I got my calculator. I'll do it. 45 over 4. 5 divided by 4. 45 divided by 4. 11.25. 11.25 grams KNO3 in 25 grams of H2O. Okay? So this stuff has a lot of details. That's why I had to split it into 2 videos. Okay? Sorry, not sorry. We'll practice in class a whole lot, but Table G is super useful, and there's a lot of things you can do and a lot of questions that work off of it. But you'll have to remember how to read the chart, how to compare and change solubility numbers if the temperature changes. You'll have to read the chart and double, triple, half, quarter, quadruple your values depending on how much solvent you've got. Okay, so see you next video. And turn off the video.